All right, everybody, so now we are going to be talking about polar molecules. We've learned about covalent bonds, and we can further label our covalent molecules as polar or nonpolar. So this all kind of starts from this idea of electronegativity. So the polarity of a bond of the joining of two molecules depends on the difference between the electronegativity values of the atoms that are forming the bond. My electronegativity is the ability to attract electrons, okay? So that's the ability of one molecule, one element to pull in electrons near it. So a nonpolar covalent bond is formed if the atoms are the same because they're going to have the same pull on electrons. Then a polar covalent bond is going to have different pulls on the electrons. So see, this negative one here is pulling the electrons a little bit more than the positive one. This here is the chart of electronegativity. You can see that we are actually missing our noble gas columns, but that's because our noble gases don't attract electrons because they don't need any more. They have a full shell. So our highest electronegativity atom, as you can see, is fluorine here. It's got a value of almost 4. And our lowest electronegativity values are over here with francium. So depending on the difference in the molecules in your bond, that will determine whether it's polar or nonpolar. A polar covalent bond is when electrons are not shared equally because one of the atoms attracts the electrons more than the other. So in this case, our fluorine has an electronegativity value of 4.0, and our hydrogen has an electronegativity of 2.1. The higher value, in this case our fluorine, is going to pull the electron from the hydrogen closer to it, which is causing a difference in the sharing of the electrons. So the fluorine is hogging them more. Then another thing to note is that water is polar. Water is not symmetrical because the oxygen hogs all the electrons there. Substances that dissolve in water are all polar. Nonpolar covalent bonds are the exact opposite. So nonpolar substances do not dissolve in water. They do dissolve in oil because oil is nonpolar. A nonpolar covalent bond is when electrons are shared equally. So you can see that I have two fluorines bonded together and they have the same electronegativity value, so they're going to share those electrons equally. Neither fluorine is going to pull the electron closer. Another thing to note is that all of our diatomic molecules are nonpolar. So again, polarity is that difference of the electronegativity values, and when the difference is 0, something is nonpolar. Another thing to note about those nonpolar molecules is that they have symmetrical shapes. So if you draw a line down the middle, and this is a mirror image of one another on the left and the right side, then you know that it's nonpolar. So here is our Lewis dot structure for chlorine, which is Cl2, because that's one of our diatomics. So there are two of them that are stuck together. Is this molecule polar or nonpolar? This one is going to be nonpolar because if we draw that line of symmetry down the middle, you can see that everything looks the same on either side. Once we decide that it looks the same, we know that these molecules are actually the same. They're both chlorines, so they're going to have the same amount of pull on the electrons, the same electronegativity. Here we're given water, the Lewis dot structure. So is this molecule polar or nonpolar? This molecule is actually polar. Water is polar, and that's one of the important things to note. Even though if you draw a line down the middle, it looks the same, we know that this oxygen is going to have a higher electronegativity, a higher pull on those electrons than both of our hydrogens. So it's really not symmetrical in real life, and that's why this is a polar molecule. All right, great job. Now is a good time. You can go ahead and write down any questions and ask the teacher or ask your neighbor when you get to class tomorrow.